Hello and welcome to our today's lecture. In today's lecture, I am going to demonstrate you how you can fill up your data sheet. This data sheet is meant for physical pharmacy 1 lab. Before submitting your final laboratory notebook, you have to complete data sheet for each and every practical. So after accomplishing each practical, you have to submit a complete data sheet. Therefore, you have to know how you can complete the data sheet. Now let's move on to our today's lecture, how you can complete your data sheet. In the data sheet, at the top left corner, there is a portion. You can write here your experiment name, experiment number, and your batch. This is not batch. This is basically your section. So experiment number will be indicated in your laboratory handbook or laboratory notebook. From the laboratory notebook, you have to pick up the experiment number. This is experiment number 1. You have to write down 01 after the experiment number. And you may be in section 2A or 2B. Therefore, you have to write your section 2A or 2B in this portion. Name of the experiment already written in this portion, and you have to fill up this date box. It is in the format of day, month, year. Today, suppose your experiment is ongoing in this date. Therefore, you can write date, day, month, and year. You have to write all these values and complete this date box. Now we have to write down your ID, identification number. Your identification number have 11 digit, starts with 05, 05, then depending on the year, it may be 20, it may be 19, 20, sorry, 20. This is the year 200. Then 10. This is for spring batch, and last 4 digit 1700. Maybe your this is your role. So this two portion has been accomplished. Experiment number, dash is not dash, it is your section, date, and your complete identification number. Okay, now suppose you have been asked to prepare 250 ml 0.5 normal, 0.5 normal, then you have to pen through this molarity 0.5 normal sodium hydroxide solution. Then you have to, at first you have to write down your problem. The problem is that you have to prepare 250 ml 0.5 normal. Therefore, I have pen through this molarity portion. Molarity is cancelled out, on the normality is prevailing. Sodium hydroxide solution using method 1 and method 2. Method 1 and method 2 has been explained in the laboratory manual. And you have to prepare another solution, which is also the volume of the solution is also 250 ml. Its strength is 0.5. Again, it is normality, and it is HCl solution, hydrochloric acid solution. So These are two problems that has been given by your laboratory instructor. You have been asked to prepare 250 ml 0.5 normal sodium hydroxide solution, and you have also another problem. In another problem, you have to prepare 250 ml 0.5 normal hydrochloric acid solution. After getting the problem, you have to write down the problem, and the writing the problem will be using the format that has been given in your data sheet, and you have to write like this: preparation of 250 ml 0.5 molarity. Since it is not a molarity calculation, so you have to cancel the molarity and the normality will prevail. So the problem should be written in this format: 250 ml 0.5 normal sodium hydroxide solution, 250 ml 0.5 normal hydrochloric acid solution. Then comes the calculation of solid reagent. Solid reagent in this case is sodium hydroxide. So your problem is you have to prepare 250 ml 0.5 normal sodium hydroxide solution. Now figure out the problem. Preparation of 0.5, you have to through the molarity. 0.5 normal, 250 ml sodium hydroxide solution. And you know that the molecular weight of sodium hydroxide, and each and every time you come across any underline, you should know that you have to fill the gap. Therefore, whenever you come across any underline, any fill in the blanks portion, you have to write something that may be any value, that may be any sentence to fill up that line. And in this case, the molecular weight of what? Molecular weight of our reagent. And our reagent is sodium hydroxide. So I have to write down sodium hydroxide in this portion. Okay, now let's write down sodium chloride. You can write down the full sentence or you can write down the chemical formula, whatever you want. Sodium, I'm going to write down the full sentence. So the hydroxide, molecular weight of sodium hydroxide is 40 gram per mole, and equivalent weight of sodium hydroxide will be 40 divided by 1. 1 is the equivalent number of sodium hydroxide, and which is equal to ultimately 40 gram. So the molecular weight of sodium hydroxide was 40 gram per mole, and the equivalent weight of sodium hydroxide was 40 divided by 1 is equal to 40 gram per mole. Here, this one is the equivalent number of sodium hydroxide, and this 40, this is the molecular weight of sodium hydroxide. You know that whenever the molecular weight is divided by the equivalent number, we can get the equivalent weight. Since we are accomplishing the normality math, so we should calculate the equivalent weight, and this equivalent weight will be used for the rest of the calculation. Okay. Now come to the chemical formula. From our mathematical formula, we know that 1000 ml, 1 normal, 1000 ml. This is a underline. This underline will contain only one entity or one particular thing, and that is 1. And this is another underline. This will contain another terms, 1 normal, and this is another underline. This underline will contain another particular thing. This is sodium hydroxide is equivalent to 40 gram. So 1000 ml 1 normal sodium hydroxide is equivalent to 40 gram. Therefore, we have to prepare 250 ml. 250 ml 0.5 normal 0.5 normal sodium hydroxide. 0.5 normal sodium hydroxide is equivalent to 40 250 ml 0.5 divided by 1000. The answer will be 5 gram sodium hydroxide. 5 gram sodium hydroxide. Okay. Our calculation is completed, has been completed, and we have to take 5 grams sodium hydroxide and take it in a 250 ml volumetric flask, add a small portion of water, completely dissolve this 5 gram and add additional amount of water to make up the volume 250 ml. But there is a problem. The problem is that the sodium hydroxide is not 100% pure. It has a definite purity. The purity of the sodium hydroxide has been given in the jar or the container of the sodium hydroxide, and in the jar it has been written that the purity of sodium hydroxide is 97%. 97% sodium hydroxide. If this 97% means it is W by W, 97% W by W. W by W means 100 gram, 100 gram contains 97 gram. W by W indicates 100 gram contains 97 gram. So we have to calculate the purity, because if we take 5 gram it from the original container, it will not provide us the exactly 5 gram of sodium hydroxide, since the purity is 97%. That means if we take 100 gram, we will get 97 gram. If we take 5 gram, we will not get 5 gram, but less than 5 gram. So we have to calculate the amount that must be taken from the container, which will provide us exactly the 5 gram of sodium hydroxide for the preparation of our intended solution. Okay. Therefore, we can say that 97 gram sodium hydroxide is present in 100 gram. Therefore, 5 gram of sodium hydroxide will be present in 5 gram sodium hydroxide will be present in 100 into 5 divided by 97, and which is 5.155 gram. So we have to take 5.155 gram sodium hydroxide from the container and dissolve it and prepare 250 ml solution. And ultimately, this solution will have the 0.5 normality strength. The strength of the final solution will have 0.5 normal. Okay, in this way, we will calculate the solid reagent. Now let's move on to our liquid reagent. We have another calculation. In that calculation, we have been asked to prepare 0.5 normal, where ml hydrochloric acid solution, and in this case almost this calculation is almost similar to the previous one. There is a slight differences because hydrochloric acid is supplied in the liquid form, and it is It has a purity which is recorded as W by W, and it has a density value. So there will be a little bit elongation of the previous calculation, but the basic thing is almost the same. Let's move on to our calculation. The molecular weight of hydrochloric acid, hydrochloric acid, molecular weight of hydrochloric acid is, we know that the molecular 36.5 gram per mole, and the equivalent weight of hydrochloric acid will be 36.5 divided by 1 is equal to 36.5 gram per mole. And in this case, you know that this 36.5 gram is the molecular weight, and this one is the equivalent number. By dividing the molecular weight with the equivalent number, we will get the equivalent weight. And this equivalent weight is used for the calculation of normality. Now, using the formula, now let's use the formula. According to the formula, 1000 ml, 1 normal, this 1000 ml, 1 normal hydrochloric acid, hydrochloric acid is equivalent to 36.5 gram. And we have to prepare 250 ml. Therefore, 250 ml, and our normality is 0.5. 0.5 normal hydrochloric acid is equivalent to 36.5, 250 ml, 0.15, and the value is 4.563 gram. 4.563 gram hydrochloric acid is required for the preparation of 0.5 normal to 50 ml hydrochloric acid solution. But hydrochloric acid is not available in the solid form. It is available in the liquid form, and the container also provides us the additional information, like the density of the substrate solution is given in the container or in the labeling of the container. And in this case, suppose the density of the substrate solution is 1.19 kg per liter. That means the density will be 1.19 gram per ml. Kg per liter and gram per ml are similar term. Therefore, we can say that 1.19 gram of hydrochloric acid, we can write it the full form, hydrochloric acid is equal to 1 ml, is present in 1 ml. Okay, 1.19 gram is present in 1 ml. Therefore, 100 gram of hydrochloric acid is present in 1.19 is equal to 84.034 ml hydrochloric acid. And the purity of the hydrochloric acid was given that it was 37. Purity of hydrochloric acid is 36%, 37%. So 37% purity indicates that 37 gram hydrochloric acid is present in 100 gram, and 100 gram hydrochloric acid is equal to 84.034 ml. That means 37 gram hydrochloric acid is present in 84.034 and we have got 4.563 gram. Therefore, 4.563 gram hydrochloric acid is present in 84.034 into 4.563 divided by 37, and which is equal to 10.363 ml. So we have to take 10.363 milliliter hydrochloric acid from the supplied container and prepare 250 ml solution. After complete dissolution, the solution will have normality, which is equal to 0.5. That means after taking 10.63 363 ml hydrochloric acid and dissolving it into 250 ml water, or preparing a solution up to 50 ml water with this 10.363 ml hydrochloric acid will give us 0.5 normal solution. And in this way, we have to accomplish the data sheet. I hope you have understood how we will accomplish data sheet. This will be very helpful for you during your lab class. And remember that if you leave any space empty, your data sheet will be regarded as incomplete. If you leave any of the gap, any of the space empty, then this data sheet will be regarded as an incomplete data sheet. Okay. Therefore, you must have to be careful when you are completing your data sheet as well as completing your notebook. Okay, that's all for this moment. I hope you have all understood today's class. Thanks to all for joining.